this topic, we are going to touch these objectives. By the end of the lesson, you will be able to differentiate between the endo and exothermic reactions, and you will be introduced to how to draw the energy profile diagram for both the reactions. So, moving further, as we know that in any chemical reaction, whenever it is taking place, there is an energy change involved. Gas energy change can be increasing the temperature of the surrounding or can be decreasing the temperature of the surrounding. So giving it a proper term, a chemistry term, or if we are using certain terminologies, in those terminologies we'll be introduced to the two new terms, exothermic and endothermic reactions. So those chemical changes in which the energy changes are taking place and the temperature of the surrounding drops, that change is called as an endothermic change. As you can see the screen, therm means heat and endo means take in the heat. So whenever a reaction is taking place and the substance or the chemical reaction, it is taking the heat from the surrounding or absorbing the heat from the surrounding, that reaction is called as endothermic reaction. So that is very obvious. If a chemical reaction, while it is occurring, it is absorbing the heat from the surrounding. So that means the temperature of the surrounding will fall down because the substance is absorbing the heat from the surrounding. So overall, during the endothermic reaction, heat is absorbed from the surrounding and the temperature of the surrounding falls down. They are very common life examples, like when we observe melting, we observe boiling, photosynthesis, or the action of light on the photographic film, or the thermal decomposition. These are all very common changes in which you observe the endothermic change. As in melting, you observe that when ice is absorbing heat from the surrounding, then what happens? The energy of the kinetic energy of the ice particles, water particles will start increasing and it becomes maximum and it will overcome the force of attraction between the particles and the particles will start getting free. So the ice which was in the solid form will start changing in the liquid form, and that process is called as melting. Same happens in the boiling. When the liquid is heated, the liquid particles will absorb heat and the kinetic energy increases. Then it becomes maximum and the liquid start converting into gas or vapors. So state is changing. So that process of boiling, observe endothermic reaction. That is an endothermic reaction because the particles of the water are absorbing heat from the surrounding. Right? So I will just add one more example to it, evaporation. After in a summer weather, after a bath, when you come out, what happens? The droplets of the water on your body will start absorbing heat from your body and the temperature of the body falls. So the water droplets on your skin will start evaporating after absorbing the heat from the skin or the body. So what will happen? The temperature of the body will decrease. So after that, you start feeling cold or you start feeling better. Same happens in the photosynthesis. That photosynthesis is a process in which plants are taking or absorbing the light or the heat from the sun in the form of light. So that absorbing the light, which is a form of energy from the sun or from the surrounding to make their food, that process is called as photosynthesis. So in that process, light is being, photo stands for light. So that light is absorbed by the plants. So that is an example of endothermic reaction. If you talk about the action of the light on the photographic film, nowadays the smartphones are very commonly used and the digital devices are very commonly used. But few years ago, when the cameras were in operation, where there was a film being used in the cameras, on those photographic films, there were a silver chloride layer was pasted, so that when the flash, when then they push the button, so what happens, the flash of the light falls on the photographic film, and that light on the photographic film will take the image of the object in front of it. So that action of light is basically oxidizing the photographic film, silver chloride in the photographic film. So what will happen, that light is actually being absorbed to carry out that chemical reaction. So that is an endothermic change. Thermal decomposition term is standing for, therm means, as I've already told you, is heat. So thermal decomposition means by using heat when certain compound is decomposed. So as heat is absorbed to decompose a certain compound, chemical compound, so that is another example of endothermic reaction. So all in all, endothermic reactions are those reactions in which heat is absorbed by the substance from the surrounding. So temperature of the surrounding falls down. The other type of the chemical reaction is a exothermic reaction, as the therm stands for heat and exo means exit, given out. So any chemical reaction or substance from which the heat is given out or the light is given out to the surrounding, so that is an exothermic reaction. When the light is given out or the heat is given out from the substance, it goes to the surrounding. So what happens?
Teacher, bonds are formed, chemical bonds.
I'm really sorry, I got disconnected. You getting my voice now? I'm really sorry, I got disconnected. You getting my voice now?
Yes,
Yes,
teacher.
teacher.
Okay, okay. Accept my apology, please. Okay, we were discussing the examples of the exothermic reaction. Among the examples of exothermic reaction, you can see condensation, freezing, respiration, combustion of the fuel, neutralization, or rusting of the metal or the iron. You can see that on the screen. So one by one, I'll explain how these reactions or the examples are involving the exothermic reaction. In the condensation reaction, actually what happens? The vapor or the gas particles condense and to convert into liquid. So condensation means the liquid or the gas or the vapor particles are coming close to each other to convert into liquid state. So in the gas, we know particles are very excited. They have maximum kinetic energy. They are moving to and here and there randomly. They are colliding with each other and the walls of the container. But when the condensation will start, the gas particles will start losing energy or heat. That energy will go to the surrounding and the particles' energy will become minimized. So when the particles lose their kinetic energy, they will slow down and start getting closer to each other. When they start getting closer to each other, the bonding develops. When the bonding develops, the state change occurs. So that state change from gas to liquid is called as condensation. And this is an example of exothermic reaction. Talking about the freezing. In freezing, what happens? The liquid freeze to the ice. I'll give a very common example of freezing water to ice. So when you're putting a pot of water in the refrigerator, what happens? The refrigerator will take out all the heat from the liquid or the water particles. Those water particles will start getting closer to each other. They will slow down. They will lose their kinetic energy. When the heat is given out, their speed slows down. They come closer to each other and they start converting into solid like ice. So that process is freezing. That is how it is giving out heat to the surrounding. Respiration is a process in which we are taking in oxygen, and the oxygen in the body that oxidizes all the food in our body to release the energy. That energy we use to carry out our daily activities. So this is how respiration is an example of exothermic reaction. In the combustion of the fuel, when any fuel we are consuming, which we are going to further talk about under this topic in our maybe next week lectures, combustion of the fuel, whenever you're using any fuel like coal, oil, natural gas, hydrogen, ethanol, any fuel, when you are burning it, what happens? that produces heat. So that is an exothermic reaction in which heat is given out of the fuel when it is oxidized with the oxygen. So that heat giving out by the combustion of the fuel is an example of exothermic reaction. Neutralization is a process. When we were studying acid and alkalis, and I was explaining that, we discussed what neutralization is. So in the neutralization, acid and alkalis, they react together to form salt and water. So that is an example of exothermic reaction. So when the acid reacts with the alkalis, heat is given out and you can feel with your hand the container will become hot. So neutralization is the exothermic reaction. Rusting is again an exothermic reaction because during the rusting process, the oxygen of the air will oxidize the metal and will produce the metal oxide and heat is given out. So that is another example of exothermic reaction. So this was what are exo and endothermic reaction. How the question you will observe in the past papers. What do you mean by the term exothermic reaction? What do you mean by the term endothermic reaction? Or give some examples, or in the form of paper 1 MCQ paper, you will observe certain options where you have to choose the exo or endothermic reactions, or further there are certain type of questions where you will be writing the examples of exothermic endothermic reaction. You'll be explaining how condensation is a exo or boiling is a endothermic reaction. So these sort of questions you will observe in the past papers. So explaining it a little bit more, exothermic reaction are the energy releasing reactions, a chemical reaction that release the thermal energy. Most chemical reaction release energy as opposed to absorbing it. So there are more reactions in which you observe the exothermic change rather than the endothermic change. So as you see, writing the chemical equation, reactant is converting to product and giving us thermal energy as well. In this, understanding this equation is very important, because when we will be drawing the energy profile diagram, then you should understand, as you see my cursor rolling here on this equation, that when the reactant will be converted to product, they are producing thermal energy. It means that the energy of the product is less as compared to the reactant. So this is the best equation to explain that why in the exothermic reactions, reactant are having more energy than the product, because while converting from reactant to product, the reactants are releasing energy which is being produced as a product. So product are having less energy as compared to the reactant. So while showing the temperature change in a graph form, as you see the screen, how does temperature change in an exothermic reaction? As we have already discussed that during the exothermic reactions, the heat is given out when the reaction is going on. So what happens? The temperature of the surrounding will increase. Suppose this 0, this is a room temperature. Sorry, after this 0, this bar shows the room temperature. So the initial temperature of the reaction mixture is here, where my cursor is. So as you will proceed, as the reaction will proceed, the temperature of the surrounding will increase, because this is an exothermic reaction. Here the reaction has completed, right? So when the reaction is complete, what will happen? The reaction mixture will start coming to the room temperature again. So this blue dotted portion shows that the reaction is occurring. Initially, the temperature of the reaction mixture rises, becomes highest, and then what happens? And then what happens? It will become maximum, reaction stops, and then it start dropping. It is just the same as you observe when you put a hot cup of tea in the room. The temperature of that tea is highest, at its highest. So after some time, what will happen? Gradually, that cup of tea, whatever the heat it is having, it will start losing into the atmosphere. So the surrounding, like as the room is quite bigger and the cup of tea is very small, so you don't observe too much change in the surrounding temperature, of course negligible change, but the cup of tea will become cooler after some time and it will come to the room temperature. So that can be a common example. So I'm reading from here. Initially the temperature of the reaction mixture rises until highest, temperature is reached. As you can see, this dotted blue portion, and then this peak is the highest temperature, means the reaction has occurred now. This is the point. After this, the temperature of the reaction mixture will start dropping to the room temperature because the reaction is completed. So when the reaction is completed, the temperature of the reaction mixture falls until it reaches the room temperature. So this is how you can express the change in temperature in the exothermic reaction. So looking at this diagram, we can easily predict how would we draw the temperature change in the endothermic reaction. Of course, the temperature will go down from the room temperature. It will go to the minimum, and then when the reaction is complete, it will come back to its original position. Let's see what we have discussed. Do we see the same? I'm going to discuss this tomorrow's lecture. So revising and adding a little bit more explanation to the endothermic reaction, which are energy absorber reactions. So for an endothermic reaction to continue, energy must be constantly added. So it means that, looking at this equation, reactant to convert into product, energy must be given to them. So they are absorbing the energy continually, which is, they have written the thermal energy. So reactant, writing the equation, reactant are taking in the heat, endothermic reaction, energy is absorbed and then converting to product. So it means product is having more energy than the reactant, because until and unless reactant absorbing thermal energy, they cannot be converted into product. So product are having obviously more energy than the reactant. So drawing it in a graph form, how does temperature change in an endothermic reaction? As I have already discussed, that from the room temperature, as the reaction proceeds, it drops down, goes to the minimum. When the reaction is completed, the temperature again start rising and comes to the room temperature. So this is how we can, from the graph, we can read and predict whether this is an exo or endothermic reaction. So graphs can easily explain us that we are talking about the exo or endo. If the temperature drops from the room temperature, that's an endothermic reaction. If the temperature rises from the room temperature, there's an exothermic reaction. So this was all about for today. And if you have any question, you can write in the comment section. I will read it and then I'm going to answer your questions